So we are going to start with the next unit, that is introduction to fuzzy logic, right? So this is related to the unit, third unit. We are going to start fuzzy logic. We have already done the neural network in 2 units, neural network part 1 and neural network part 2. Now, we need to first understand the introduction to fuzzy logic. That means what we are going to do in fuzzy logic, why we are using fuzzy, what does fuzzy means, and so many more questions we are going to answer in this lecture. Now see, the word fuzzy means what? We have already seen the fuzzy word means the vagueness. Vagueness is whatever that is not clear, whatever that is not giving you the exact answer, that particular thing is termed to be as fuzzy. If I say in simple terms, which is confusing, whatever it is confusing is fuzzy. If I ask you a question and that particular question gives you an exact answer, so that means that is crisp. And if it does not gives you a exact answer, it gives you a confusing point, it does not gives you a clear boundary, so that particular piece of information is the fuzzy, is what is vague. So that you have to remember regarding the fuzzy, that is vagueness, not clear cut, when the boundaries of a piece of information is not clear cut. Now see, same example, if I take whether it's raining outside, so the answer is simple, either yes or no. If it is raining, I'll give you the answer yes, and if it is not raining, I'll give you the answer no. But if I ask you whether this person is honest or not, so I cannot say the exact thing whether he is honest or not. For me, he can be honest. For the other person, he cannot be honest. You cannot clearly define, but I can define the degree of honesty, right? I can say that he is not at all honest. He is somewhat honest. He is okay. Sometimes he seems to be honest and sometimes he is not. So it does not give you the clear cut answer. It does not have clear boundary, clear cut information. So this is what, this is coming under the category of fuzzy. So this is how the fuzzy is defined in a simple term. Now fuzzy sets, these particular have been introduced by the person who is called as Lofty A. Zadeh in 1965. And that is an extension of classical notation of sets. Now, what is classical notion of set? We have already studied certain classical set theory. We have already done in, you must have studied in discrete structure also. That is set theory you must have done. So that particular classical set theory, when extended, is termed to be as in fuzzy sets. It is useful in answering so many questions which are of real world problems, which are not confined to yes or no, to 0 or 1, but they are somewhat extended in terms of real world problems. When we come to real world problems, all the real world problems does not give you the answer which is clear cut. It gives you, it defines the degree. Sometimes it gives you a confusing answer. Sometimes it gives you a probability, such as probability of raining today. So you cannot easily say that yes, it is going to rain, or no, it is not going to rain. So that particular is confined or depending on the probability, depending on certain parameters. So that is what the fuzzy set is, right? So this is the basic introduction of fuzzy. Now, these two are the opposite terms when we use the fuzzy and the crisp. As I told you right now also, that a proposition can be true or false only. When a proposition is either true or false only, that particular degree of truth is 0 or 1. That means the degree of truth depends on two parameters only, that is either 0 or 1. If it is 1, it is true. If it is 0, it is false. So there is nothing in between 0 and 1. It is 0 or 1, not 0 and 1, right? So just focus on this point, or 0 or 1. The degree of truth is 0 or 1. But So here I have taken an example. Bob is a student. True or false? If Bob is a student, then true. If Bob is not a student, then it is false. So it does not have that Bob, yes, Bob is also a student and he is somewhat student, he is partly student. No, there's no partial theory in this. It is very clear cut that either he is a student or he is not a student. When we say smoking is healthy, false. So it is very clear cut, nothing in between. Nothing in between the degree of truth, 0 or 1 or true or false. It gives you a clear cut and exact answer. Now, when we say fuzzy, fuzzy have the degree of truth is between 0 and 1. Now, see, I have told you here the focus is on 0 or 1, and here the focus is on 0 and 1. That means the numbers between 0 and 1 can also be taken in terms of degree of truth, such as if it is said as William is young, so young cannot be, young is a term or young is a point which cannot be defined with the exact age, that yes, 20 is the age of young, 25 is the age of young, 35 can also be a age of young, right? So we have to define what? We have to define the degree of truth. So 0.3, we say 0.3, that means he is not very young. He's not exactly young, but yes, he is coming under the category of young. So that is defining the value 0.3 between 0 and 1. Next, I have taken Ariel is smart. Now, smart has a different definition for everyone. For each person, it has a different. So we have a degree of truth, which is defined out here as 0.9. So we can say for maximum people, he is termed to be as smart. So I have given it the close value of 1. So 0 being the false and 1 being the true. So the values which are close to 0, they are being defined close to the value of false, and 0.9, it is the value which is close to the value 1, so it is closer to the true value. Okay, so that is what fuzzy is. When we define the degree, we can also take one more example. What is it? It is like whenever you attend a workshop or an expert talk, you give a feedback about the session, or about the facilitator who is giving you the instructions. So on that basis, you cannot say yes, the session was fruitful, or no, the session was fruitful. But there are degree of possibilities that yes, the session was very fruitful, but it was of limited time. So there is partial truth in this. So that is what fuzzy is, defining the degree, right? So I have taken an example, like we have seen the words like young, tall, good, high. These are all the words which are termed to be as fuzzy. I cannot have a specific age below which or above that is young or not, clear cut. Same with the tall, same with good, same with high. So there is no single quantitative value. I do not have any quantitative value which defines the term young. I cannot say that 20 20 is the age which is defined to as young. No. So what it is, for some people age 25 is young, and for others age 35 is young. The concept young has no clear boundaries. That means it does not have the clear cut boundaries that yes, from 20 to 30 it is what it is, the young. Age 1 is definitely young, and age 100 is definitely not young. That we know, that age 1 is definitely young, but the person who is of age 100 is definitely not young, right? Age 35 has some possibility of being young, and usually depends on the context in which it is being considered. So it depends where we are using this particular term as young. So accordingly we will give, or we will define the degree of truth. It can be, it will be from 0 to 1. That means somewhere in between 0 and 1, but not exactly as 0 or 1, right? So that is what we have taken the example out here. Now fuzzy logic is what? We have seen what is fuzzy. Now we are going to see what does fuzzy logic means. Fuzzy logic is a method of reasoning, that resembles the human reasoning. When we say it is very easy to give the values or give the computation through calculator or through machines that which gives you the answer of yes or no, which are clear. But the questions which need to be have the reasoning point and give you a answer which is between 0 and 1 is what is related to the human reasoning. So that is why we are saying that fuzzy logic is going to resemble the human reasoning when we are using the method of reasoning. Now, this approach of fuzzy logic imitates the way of decision making in humans that involves all intermediate possibilities between digital values, yes and no. That means this fuzzy logic is going to imitate, is going to resemble the way we humans are making the decisions. How we humans are making the decisions? We are making the decisions based on our prior or the past experience through analysis of certain parameters. So the same fuzzy logic will be used here. Now, the fuzzy logic works on the levels of possibilities of input to achieve and definite output. That means when we have the input possibilities, we have certain inputs which are not definite. We do not have definite inputs, but we are going to achieve the definite output. That time we are going to use the fuzzy logic. The conventional logic block that a computer can understand takes precise input and produce a definite output. That is what I told you earlier also. That is conventional logic. The computer is using what? It takes a precise input and it gives you a definite output, which is in terms of true or false, which is equivalent to humans yes or no. So we are not going to focus on these particular points because we have so many methods in which we can easily find the answers to the problems which can give you the exact answer of yes or no. But now we are focusing on the problems which are real world problems which need the way the humans are making decisions or the way the humans are going to present their reasoning to analyze and to give the decision on a particular query. This is what we have in between yes or no or between true or false. The inventor of fuzzy logic, Lotfi Zadeh, observed that unlike computers, human decision making includes a range of possibilities. Focus on this term, range of possibilities between yes and no, such as it is certainly yes, possibly yes, cannot say, that means neutral. It can be yes or it can be no, possibly no, and certainly no. So it is what it is defining. Whenever the question is asked to you on basis of defining the degree of truth on the basis of or on the scale rate the person on the scale of 0 to 1, sorry, 0 to 5, that is what we are doing out here, right? We are defining the degree of truth with the help of these possibilities. Now, where we are you going to use this fuzzy logic? What are the applications? We are first of all using this in commercial and practical purposes, right? It can be used in control machines and consumer products. We have a lot of areas in which we are using fuzzy logic. It may not give accurate reasoning, but it gives you acceptable reasoning. That means we are not sure that we are going to get the accurate and exact answer, but obviously, yes, it is going to give you a acceptable answer which is nearby the reasoning point. Fuzzy logic helps to deal with the uncertainty in engineering. That is the most important point. That is, wherever the input is not certain, wherever there is uncertainty, wherever the input is not precise, wherever the input is not clear, at that particular point, we are going to use the fuzzy logic in the engineering problems. Now, in real world, there exists fuzzy knowledge. Knowledge that is vague, these are the words which we are going to use, imprecise, uncertain, ambiguous, inexact, or probabilistic in nature. At that point, we are going to use the fuzzy logic, right? So these are the points which we need to remember where we can use the fuzzy logic. Wherever the knowledge is vague, imprecise, that means not precise, uncertain, which is not clear, ambiguous, again unclear, inexact, we are not having the exact answer, or probabilistic in nature, that is what I told you, that we depend on the probability of the past experience and then we analyze and reason the current situation and give our decision. So that is what we are using the fuzzy logic. That's all for this lecture. Thank you very much.